Boom! All right, so we are continuing where we left off in the last question. All right, and this is where we left off, so we're continuing. So we now have to factorize g of x. Okay, I think I missed out one thing here in the write-up for this question. I was supposed to actually put factorize gx completely, all right? Complete ly, right? So completely, yeah, completely, right? Okay, so we're factorizing g of x completely. Remember the marker? Okay, good. Yeah, I'm walking around here like if I'm in a normal class, right? Yeah, we're not necessarily trying to be perfect. The important thing is that we transmit the information, and that once you get the information, you use it the way you're supposed to use it. Yeah? So we want to factorize g of x completely. This is the operative word, because having gone through this, and I'm going to leave this on the board and rub off this side. Having gone through that, we could then write, and I'm going to write over everything here now. Right? So part 1, the write-up would be that f of x is equal to g of x over h of x. Therefore, h of x is equal to f of x over g of x. Equal, ding, 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 ding. You do your work over here, and you come here now. H of x is equal to x squared minus 2x minus 3. That is how you would proceed. So we clear that. Now we're factorizing g of x complete. Not g of x, sorry. You see how much mistakes I make? That has happened when you're pushing. This should be factorized f of x completely. Alright, so my humble apologies for the errors, but you'll understand what it is we're trying to do here, right? It don't make sense starting over and doing the next recording. Already had to start over with this particular recording because of a particular issue with the technology, so I'm not going to start over again. The idea is that you know what happened there. So it's just like a real class, right? A real class, you know, sometimes the teacher stand up talking and he'll write something on the board and the students would point it out to him and then he had to make a correction. Sometimes he would pick up the mistake himself or herself, etc., etc. So we're dealing on a real here now. Yeah? So we want to factorize f of x completely. So if we're doing that, the first thing we need to do is say that we go back to the beginning. F of x is equal to g of x by h of x, which is, this is your g of x here, x squared plus, x squared plus 2x minus 35 in brackets by x squared minus 2x minus 3 in brackets. So g of x by h of x. So this is your first level of the factorization. That is your first stage of the factorization. The explicit and deliberate use of the word completely, which is something you will see in many a maths exam. Even at the level of C-Sec maths, they will say factorize completely. Right? And I think I would have gone through that in the question before this one, but repetition never hurts. Factorize completely, okay, good, means that it implies that there is further factorization to be done after the first factorization. So we clear the space now, and in a situation like this, you know that the factorization that they will be referring to would be a factorization of this quadratic into two linear factors, and the answer for this would just be 7 minus 2, x 7 minus 5, x plus 7 into x minus 5. Yeah. And this would be minus 3 plus 1. X minus 3 into x minus 3 plus 1. Yeah, and x plus 1. Minus 3 plus 1. Alright? Right, and that is your factorization. So when you factorize this, you get x plus 7 into x minus 5 into x minus 3 into x plus 1. And that's it. So now that you have this as the final factorization, we have to go on to the next step now, which is to determine the roots of the equation. And if you would have recalled, the original equation was that f of x equal 0. So now I'm going to start in the bottom here, and I'll probably come across here and do another reason. So we're rubbing off this blue here. Alright, double check the time. Okay, we're not doing too badly at all. And part 3, we're saying that if f of x is equal to 0, we are not going to come and say x4 minus 42x squared plus 64x plus 105 equals 0. We're not going to do that, right? Because that is just going backwards. You go through all of this and all of this to express f of x as this, to go back and write this. That doesn't make any sense. That doesn't make any sense. So what do? We take the form of f of x, the simplified form that we already have, and we equate that to 0. So in part 3, you start off by saying that f of x is equal to 0, which is to say then that, sorry, I should use therefore instead. Therefore, x plus 7 into x minus 5 into x minus 3 into x plus 1 is equal to 0. And this is where we go back now to the irregular arithmetic that we were doing in your C-Sec maths in question 2. So I'm going to rub off this side of the board now to finish the question. Okay. Right. So we know now, there's a whole video in the maths on the foundation for this. That video is the title of the video is Solution of Quadratic Equations. Alright, so you take a quadratic equation and you boil it down to some quadratic being equal to 0. Boom. You go through steps. So I'll just do a quick revision of it by way of talking. We know that the product of these 4 entities is equal to 0. What does that mean? All it means is that you only need one of those entities to be equal to 0. If A multiplied by B is equal to 0, if A is equal to 0 or B is equal to 0, the whole thing will be equal to 0. If A by B by C by D is equal to 0, then you only need one of A, B, C, or D to be equal to 0 for the whole product to be equal to 0. If the product of all the letters in the English alphabet is equal to 0, that's 26 factors. You only need one. So if M is equal to 0, the whole product is 0. If Q is equal to 0, the whole product is equal to 0. If D is equal to 0, then the whole product is equal to 0. So we take that logic and we apply it here. What that means is that we'll have to consider each case of one of these entities being equal to 0. So how do we write that in a situation where we're explaining something to an examiner somewhere? All right? So we continue on part 3 now, and we're saying, we say either we start with the first one, x plus 7 is equal to 0, in which case x equal minus 7, or go to the second one now, x minus 5 equals 0, in which case x equal 5, or you go to the next case now, x minus 3 is equal to 0, in which case x equal 3, or x plus 1 is equal to 0, in which case x is equal to minus 1. Yes? So we now have 4 values of x. We have x equal minus 7, x equal 5, x equal 3, and x equal minus 1. So in other words, if we have an expression of degree 4, an equation, of degree 4, where you have a quartic polynomial being equal to 0, then you will get 4 solutions or 4 roots, to use a different terminology. Right? We had to get familiar with all the different mathematical lingo now. Right? So these are your 4 answers here. X equal minus 7, x equal 5, x equal 3, and x equal minus 1. In the same way that when it's a linear equation, you have 1 value of x. And when it's a quadratic equation, you have 2 values of x. And when it's a cubic equation, you have 3 values of x. If you're solving a quartic equation, or an equation where the function is of degree 4, a polynomial of degree 4, then you will have 4 values of x. And you had to be comfortable dealing with that. So at the level of CSEC maths, you would generally have to deal with solving quadratic equations. Alright, even in section 2, where you have simultaneous equations where you're dealing with one linear and one quadratic, it will eventually boil down to either 1 or 2 quadratics to find the 2 values of x and the 2 values of y. Alright? In ADMATS, we take it a step further. We're going into cubic, degree 3, quartic, degree 4, as prescribed by the syllabus itself. Alright? So this is what we would have been doing. Up to this stage, we would have dealt exclusively with long division, where we don't have a remainder. So the next step naturally would be to do some long division where we actually have a remainder. And then once we do that, we then make the link to the remainder and the factor theorem. Alright, which it sounds like something fancy, but if you go through all of this with me, and I go to the next step, which is to do long division with remainder, by the time we get to the remainder and the factor theorem, you will see that it's just a simplified version of all of this complexity here. Alright, so I want to encourage you again, take the ADMATS seriously, take the questions seriously. Alright, ADMATS is a different level to maths. I want to underscore that. Right, I want to underscore that. So there's a different level of application, a different level of concentration, a different level of persistence required to succeed and to do well in ADMATS. Alright, so keep good, take care, continue enjoying the stuff. Of course, you're always welcome to bring more people in the game, and let me get the job done.